The National Electrical Code, specifically Section 430.125, addresses the requirements for protecting inverter duty motors. These motors, which are designed to operate with variable frequency drives, or VFDs, are subject to specific overheating risks. The code mandates that inverter duty motors must be protected against overheating, and this protection needs to address two primary scenarios: firstly, overloads, and secondly, failures of the associated inverter drive. Overloads occur when the motor is subjected to excessive mechanical load, causing it to draw more current than its design allows. This increased current generates additional heat within the motor windings and other components. Without adequate protection, the motor's temperature can rise to levels that damage the insulation, reduce its lifespan, or even cause catastrophic failure. Inverter drive failures can manifest in various ways, such as the drive outputting incorrect voltage or frequency, or the drive's control circuitry malfunctioning. These failures can lead to the motor operating inefficiently, drawing excessive current, or experiencing harmonic distortion, all of which contribute to overheating. To satisfy the code requirements, a thermostat or other approved over-temperature device must be provided. A thermostat is a temperature-sensitive switch that is embedded within the motor windings or attached to another critical component. When the temperature exceeds a predetermined threshold, the thermostat opens, interrupting the power supply to the motor or signaling the VFD to shut down. This prevents the motor from reaching dangerously high temperatures. There are several types of thermostats that can be used for motor protection, including bimetallic thermostats, which use a bimetallic strip that bends in response to temperature changes, and thermistors, which are temperature-sensitive resistors whose resistance changes with temperature. The choice of thermostat depends on factors such as the motor's size, operating environment, and the desired level of protection. Other approved over-temperature devices may include resistance temperature detectors, or RTDs, and thermocouples. RTD are sensors that measure temperature based on the change in resistance of a metal wire. Thermocouples are sensors that measure temperature based on the voltage generated at the junction of two different metals. Both RTD and thermocouples provide continuous temperature monitoring and can be integrated with the motor protection relay or VFD to provide advanced protection features such as temperature trending and alarm annunciation. The selection of an appropriate over-temperature protection device should be based on several factors, including the motor's thermal characteristics, the operating environment, and the specific requirements of the application. The device should be rated to withstand the motor's maximum operating temperature and should be installed in a location where it can accurately sense the motor's temperature. It is also important to ensure that the device is compatible with the motor's control circuitry and that it is properly calibrated to provide accurate temperature readings. In addition to providing over-temperature protection, it is also important to ensure that the motor is properly sized for the application and that it is operated within its rated voltage and current limits. Overloading a motor or operating it outside of its design parameters can lead to overheating and premature failure, even if over-temperature protection is provided. It is also important to regularly inspect the motor and its associated components for signs of wear and tear and to perform preventive maintenance as needed. This includes lubricating bearings, cleaning cooling fins, and checking for loose connections. By taking these steps, it is possible to extend the life of the motor and prevent costly downtime. In summary, NEC Section 430.125 requires that inverter duty motors be protected against overheating due to overloads and inverter drive failures. This protection must be provided by a thermostat or other approved over-temperature device. The selection and installation of the protection device should be based on the motor's thermal characteristics, the operating environment, and the specific requirements of the application. In addition to providing over-temperature protection, it is also important to ensure that the motor is properly sized and operated within its design parameters and that it is regularly inspected and maintained. The National Electrical Code Article 430 covers motors, motor circuits, and controllers. Within Article 430, Section 430.125 specifically addresses protection of motors used with adjustable speed drive systems. These systems, also known as variable frequency drives or VFD, introduce unique challenges to motor protection due to the potential for harmonic distortion and other electrical anomalies. Harmonic distortion refers to the presence of unwanted frequencies in the electrical waveform. These frequencies can cause increased heating in the motor windings and other components, leading to premature failure. VFD can also cause voltage spikes and other transient events that can damage motor insulation. Section 430.125 mandates that motors used with adjustable speed drive systems be protected against overheating. This protection can be provided by a variety of means, including thermal overload relays, thermostats, and other approved devices. Thermal overload relays are devices that sense the current flowing through the motor windings and trip the circuit breaker if the current exceeds a predetermined level. These relays are typically installed in the motor starter or controller. Thermostats are temperature-sensitive switches that are mounted in the motor windings. When the temperature of the windings exceeds a predetermined level, the thermostat opens, tripping the circuit breaker or signaling the VFD to shut down. Other approved devices may include resistance temperature detectors, RTDs, and thermocouples. RTD are sensors that measure temperature based on the change in resistance of a metal wire. Thermocouples are sensors that measure temperature based on the voltage generated at the junction of two different metals. Both RTD and thermocouples provide continuous temperature monitoring and can be integrated with a motor protection relay or VFD to provide advanced protection features such as temperature trending and alarm annunciation. The selection of the appropriate over-temperature protection device depends on several factors, including the motor size, operating environment, and the specific requirements of the application. It is also important to consider the cost and complexity of the different protection options. In addition to providing over-temperature protection, it is also important to ensure that the motor is properly sized for the application and that it is operated within its rated voltage and current limits. Overloading a motor or operating it outside of its design parameters can lead to overheating and premature failure, even if over-temperature protection is provided. It is also important to regularly inspect the motor and its associated components for signs of wear and tear and to perform preventive maintenance as needed. This includes lubricating bearings, cleaning cooling fins, and checking for loose connections. The NEC also provides specific requirements for the location and installation of motor protection devices. For example, Section 430.102 requires that motor disconnecting means be located within sight from the motor and the driven machinery. This ensures that the motor can be safely disconnected from the power supply in the event of a malfunction. Section 430.109 specifies the types of disconnecting means that are permitted for different motor sizes and applications. In general, the disconnecting means must be capable of interrupting the motor's full load current. The NEC also addresses the requirements for motor control circuits. Section 430.71 defines the different types of motor control circuits, including starting circuits, stopping circuits, and interlocking circuits. Section 430.72 specifies the requirements for overcurrent protection of motor control circuits. In addition to the NEC, other standards and regulations may apply to the installation and operation of motors. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for motor performance and dimensions. The Occupational Safety and Health Administration, or OSHA, also has regulations that address the safety of electrical equipment in the workplace. It is important to be familiar with all applicable standards and regulations before installing or operating a motor. Failure to comply with these requirements can result in fines, penalties, and even legal action. In summary, the NEC provides comprehensive requirements for the protection of motors, including those used with adjustable speed drive systems. Section 430.125 specifically addresses the need for over-temperature protection for these motors. The selection and installation of the appropriate protection device depends on several factors, including the motor size, operating environment, and the specific requirements of the application. It is also important to be familiar with other applicable standards and regulations, such as those published by NEMA and OSHA. The use of explosion-proof motors in conjunction with variable frequency drives, or VFDs, introduces unique safety considerations. Explosion-proof motors are designed to contain any internal explosions that may occur due to the presence of flammable gases or vapors in the surrounding atmosphere. These motors are typically used in hazardous locations, such as chemical plants, refineries, and mines. When an explosion-proof motor is used with a VFD, it is important to ensure that the entire system is properly designed and installed to prevent the risk of explosion. The VFD can generate electrical sparks or arcs that could ignite flammable materials. Therefore, the VFD must be installed in a non-hazardous location or in an explosion-proof enclosure. The motor and VFD must also be properly grounded to prevent the buildup of static electricity. In addition to the explosion hazard, VFD can also generate harmonic distortion, which can damage the motor and other electrical equipment. Harmonic filters may be required to mitigate the effects of harmonic distortion. It is also important to ensure that the motor is properly rated for use with a VFD. Inverter duty motors are specifically designed to withstand the stresses imposed by VFD. These motors have enhanced insulation and cooling systems to prevent overheating. The NEC provides specific requirements for the installation and wiring of explosion-proof motors. Section 500.8 specifies the types of wiring methods that are permitted in hazardous locations. These wiring methods include rigid metal conduit, intermediate metal conduit, and cable with a gas-tight jacket. All electrical connections must be made in explosion-proof enclosures. The NEC also requires that explosion-proof motors be marked with the class, division, and group of the hazardous location for which they are approved. This information is used to ensure that the motor is suitable for the specific environment in which it will be used. It is important to consult with a qualified electrical engineer or contractor before installing an explosion-proof motor and VFD system. These professionals can help to ensure that the system is properly designed, installed, and maintained to prevent the risk of explosion. In summary, the use of explosion-proof motors with VFD requires careful consideration of safety issues. The VFD must be installed in a non-hazardous location or in an explosion-proof enclosure. The motor and VFD must be properly grounded to prevent the buildup of static electricity. Harmonic filters may be required to mitigate the effects of harmonic distortion. It is also important to ensure that the motor is properly rated for use with a VFD. The NEC provides specific requirements for the installation and wiring of explosion-proof motors. It is important to consult with a qualified electrical engineer or contractor before installing an explosion-proof motor and VFD system. Inverter duty motors are specifically designed to be used with variable frequency drives, or VFDs. These motors have several features that make them suitable for VFD applications, including enhanced insulation, improved cooling, and a wider speed range. Enhanced insulation is necessary to withstand the voltage stresses imposed by VFD. VFD can generate voltage spikes and other transient events that can damage motor insulation. Inverter duty motors have thicker insulation and are made with materials that are more resistant to voltage breakdown. Improved cooling is necessary to prevent overheating. VFD can cause motors to operate at higher temperatures than they would if they were connected directly to the power line. Inverted duty motors have larger cooling fans and improved ventilation to dissipate heat more effectively. A wider speed range is necessary to take advantage of the capabilities of VFD. VFD can control the speed of a motor over a wide range from very slow to very fast. Inverter duty motors are designed to operate efficiently over this wide speed range. In addition to these features, inverter duty motors are also typically designed to be more energy efficient than standard motors. This is because they are optimized for use with VFD, which can reduce energy consumption by matching the motor's speed to the load requirements. When selecting an inverter duty motor, it is important to consider the following factors. Firstly, the motor's horsepower rating. Secondly, the motor's voltage rating. Thirdly, the motor's speed range. And fourthly, the motor's enclosure type. The horsepower rating should be sufficient to meet the load requirements of the application. The voltage rating should match the voltage of the power supply. The speed range should be wide enough to accommodate the desired range of motor speeds. The enclosure type should be appropriate for the environment in which the motor will be used. In summary, inverter duty motors are specifically designed to be used with VFD. These motors have several features that make them suitable for VFD applications, including enhanced insulation, improved cooling, and a wider speed range. When selecting an inverter duty motor, it is important to consider the motor's horsepower rating, voltage rating, speed range, and enclosure type. The National Electrical Code Section 430.125 requires that motors rated for inverter duty shall be protected against overheating due to overloads and failure of the associated inverter drive. Therefore, a thermostat or other approved over-temperature device shall be provided. This protection is crucial because inverter duty motors, while designed for variable frequency drives, are still susceptible to thermal stress from various sources. Firstly, harmonic distortion is generated by the VFD, leading to increased heating in the motor windings. Secondly, low speed operation reduces the effectiveness of the motor's cooling fan. Thirdly, rapid acceleration and deceleration cycles can create thermal spikes. The NEC mandates that these motors have built-in thermal protection, such as thermostats or resistance temperature detectors or RTD, that trip the motor offline when a certain temperature threshold is reached. The specific type of over-temperature device use can vary depending on the motor's design and application. Thermostats are simple, cost-effective devices that directly break the motor circuit when the temperature exceeds a set point. RTD provide continuous temperature monitoring and can be integrated with the VFD to provide more advanced protection features. In addition to the NEC requirements, motor manufacturers often recommend specific over-temperature protection devices for their inverter duty motors. These recommendations should be followed to ensure that the motor is adequately protected. It is also important to properly install and maintain the over-temperature protection device. The device should be located in a position where it can accurately sense the motor's temperature. The device should also be regularly tested to ensure that it is functioning properly. Over-temperature protection is not a substitute for proper motor sizing and application. The motor should be sized to meet the load requirements of the application without being overloaded. The motor should also be operated within its rated voltage and frequency limits. The use of VFD can significantly improve the energy efficiency of motor-driven systems. However, it is important to be aware of the potential for overheating and to take steps to protect the motor from thermal stress. By following the NEC requirements and the motor manufacturer's recommendations, it is possible to ensure that inverter duty motors operate safely and reliably. The term explosion-proof as it relates to motors does not mean that the motor can withstand an external explosion. Rather, it means that the motor is designed to contain any internal explosion that may occur due to the presence of flammable gases or vapors in the surrounding atmosphere. Explosion-proof motors are typically used in hazardous locations such as chemical plants, refineries, and mines, where there is a risk of explosion. These motors are constructed with heavy-duty enclosures that are designed to withstand high pressures. The enclosures are also designed to prevent sparks or flames from escaping and igniting the surrounding atmosphere. Explosion-proof motors are typically certified by a third-party testing laboratory, such as Underwriters Laboratories or UL, to ensure that they meet the requirements of applicable standards. The certification mark indicates that the motor has been tested and found to be suitable for use in hazardous locations. When selecting an explosion-proof motor, it is important to consider the class, division, and group of the hazardous location in which it will be used. The class indicates the type of hazardous substance that is present. The division indicates the probability of the hazardous substance being present. The group indicates the specific hazardous substance that is present. Explosion-proof motors are also available with different temperature codes. The temperature code indicates the maximum surface temperature of the motor. It is important to select a motor with a temperature code that is below the ignition temperature of the hazardous substance that is present. In addition to explosion-proof motors, there are also other types of motors that are suitable for use in hazardous locations. These include totally enclosed fan-cooled or TEF motors and non-incentive motors. TEF motors are designed to prevent the ingress of dust and moisture. Non-incentive motors are designed to prevent sparks or arcs from being generated. The selection of the appropriate type of motor for a hazardous location depends on the specific requirements of the application. It is important to consult with a qualified electrical engineer or contractor to ensure that the motor is properly selected and installed. In summary, explosion-proof motors are designed to contain any internal explosion that may occur due to the presence of flammable gases or vapors in the surrounding atmosphere. These motors are typically used in hazardous locations. When selecting an explosion-proof motor, it is important to consider the class, division, and group of the hazardous location in which it will be used. It is also important to consult with a qualified electrical engineer or contractor to ensure that the motor is properly selected and installed.